In this area of bringing together both product design and manufacturing, there's a whole host of sub areas that we could look at, and certainly our focus here in this lab is on how plastics behave. As you put plastics into place to make actually the geometry, the structure of the part, how does that reinforcement, these little fibers that you might put in there, how do they help you? Okay, because obviously if we're going to add fibers to the plastic, we would like for them to be positioned in such a way that they're the most help, right? So we do that through a few ways. We do some design and, like I said, some simulation work where we're actually modeling the flow of the plastic as it's being put into place, whether in a very popular process that's used in industry is extrusion. And so we do extrusion simulation where we're looking at how the polymer comes through a die and then exits and then forms the part, and then how did the plastic or the reinforcement follow along and provide that extra strength and stiffness. We'd like to then know, is the plastic strong enough, so we're able to do some work with analysis and simulation, and then of course we can make the parts and we can test them as well. One of the areas that we've been doing a lot of work in lately is in 3D printing, and an area that's picked up in the last 3 to 4 years is what we would call large-scale additive manufacturing, where we're taking, rather than limiting ourselves to what you might do on the desktop, which is very popular. You can buy these little desktop machines and do some parts relatively small, and they still take an hour to build. What we're looking at is, at this point, building things that are on the order of feet in size. So we've just finished or put together our first table to do what we call large-scale additive manufacturing, and in fact it's what's behind me here. And in this case, and it's not all together yet, but in this case we're able to have a build platform that is on the order of about 4 feet by 4 feet, and at this point it's about a half foot tall. So we're working on getting it taller, but ideally we'd like to be able to do about 4 feet by 4 feet by 2 feet, something along those lines. And we're looking at different polymers to run through the process, some with reinforcement and some without. And so this gives us a chance to really study closely the flow patterns, the temperature patterns of what happens to the plastic after it comes out of the nozzle. Another area that we look at as far as this integration of product and processing is a technique called topology optimization. We've got some students working on that, and topology optimization really tries to answer, it's an optimal design method for defining where to put material. So it really tries to answer the question, if I have a box and I want to put material, or a region of space, and I want to put material in it to carry some load, where's the best place to put that material? I obviously don't want to fill up the whole region with material. That would require way too much material, and if I went to print it, whether I print it on large scale or in small scale, it's going to take forever to fill up a whole box. It would actually be non-engineering to do that. So what we'd like to be able to do is say, you know what, I've got this region of space and I want to fill it with, say, 30% of that volume with material. Now where's the best place to put that 30% of material? And it gets a little trickier when we start to look at things like, now we can actually reinforce it with fibers in the polymer material itself. And so now how does the fibers affect where I want to place the material? So it's actually quite an interesting problem that comes up. This is all merged together with 3D printing. Topology optimization has been around since the late 80s, and it's been used in industry pretty regularly. However, a lot of things that you can actually design on the computer you can't build. Okay, so it comes up with these strange designs that there's no way you could ever make a part in the manufacturing world to that shape. However, now with the increasing use of 3D printing, you can pretty much print whatever detail you want in the part. So now, if we come up with some strange, what would normally be considered a strange shape for an engineering design, we can actually go print it because we have all the flexibility that 3D printing brings along with it. So it really is quite a nice combination of two technologies. That is the 3D printing technology, where we're making parts, in this case out of plastic with reinforcement. We're using the reinforcement, we want to position it in just the right place. We can go to the topology optimization to figure out what is the structure that we need to carry the loads, and then not only that, what is the structure we need to take best advantage of this plastic and the reinforcement that we have.